All right, hello. Geometry Notes 1.3. In this section, some of the vocabulary you'll be talking about, or will be talking about: angle, vertex, interior of an angle, exterior of an angle, measure, degree, acute angle, right angle, obtuse angle, straight angle, congruent angles, and angle bisectors. Hopefully, some of those words you are already familiar with. Well, example 1. A surveyor recorded the angles measured by a transit, point A. Let's see, the rest of this. There you go. And 3 distant points, B, C, and D. Name 3 of the angles. There are 3 angles there. And we start off with this symbol like this. That's the symbol for an angle. One of the small angles maybe on the left would be B, A, C. The vertex is A, or the vertex is the hinge point. That letter A has to go in the middle. A second angle could be angle CAD. A third angle could be the big angle, angle BAD. Now, there's 3 angles, but we could also write these in a different order. Like this first one could be angle CAB. The second one could be angle DAC. See, all I'm doing is reversing the letters, but I have to have the vertex in the middle. This last one would be DAB. Again, lots of ways of naming angles. On your next slide, the measure of an angle is usually given in degrees. Usually because if you go into trigonometry, it's going to be in what's called radians. But for this class, it's always going to be degrees. Since there are 360 degrees in a circle, 1 degree is 1/360th of a circle. When you use a protractor to measure angles, you are applying the following postulate. Below is postulate 131, the protractor postulate, which reads, given line AB and a point O on line AB, all rays that can be drawn from O can be put in a 1-to-1 correspondence with real numbers from 0 to 180. In other words, all of the angles that we're going to measure in this class are anywhere from 0 degrees up to 180 degrees. Here are 3 specific kinds of angles. The first one is an acute angle. Measures greater than 0, less than 90. That's your small angles. The second one is a right angle. That measures exactly 90. Notice the box in the corner. Highlight it in red right there. That little box in the corner means 90 degrees. The third one, obtuse angle, measures greater than 90 and less than 180. So that's your big angles. The fourth one is called a straight angle. It's basically a line formed by 2 opposite rays and measures 180, exactly 180. If you look at this example, you have a protractor there. Find the measure of each angle, then classify each as acute, right, or obtuse. Well, the first one, A, it's angle WXV. Let's find that angle. WXV would be this angle right here. I'll mark it with a little mark here. WXV. And if you read the protractor, it looks like it's going to be that 30 right there. So that angle is 30 degrees. Would that make it acute, right, or obtuse? And you should know that's an acute angle. The second part here, the angle of ZXW. Go to a different color here. ZXW would be this angle right here. Well, if you read this right here, that number is 130, but we have to subtract this 30 over here. So the angle here is 100 because this angle in here is 30. So the angle is 100 degrees, and that makes it obtuse. So we had to do some subtracting there to get it done. Next slide. Congruent angles are angles that have the same measure. In the diagram, the measure of angle ABC equals the measure of angle DEF. So you can write angle ABC is congruent, remember that symbol right there, it's the congruent symbol, is congruent to angle DEF. This is read as angle ABC is congruent to angle DEF. Arc marks. Remember in the previous lesson we had tick marks. Now arc marks are used to show that two angles are congruent. I'll highlight them. It's these little marks in the middle of these angles. Those are called arc marks, and they're used like tick marks to show congruency. The angle addition postulate is very similar to the segment addition postulate that you learned in the previous lesson. Here it is, postulate 132, angle addition postulate. If S is in the interior, meaning inside the angle, of angle PQR, then the measure of angle PQS plus the measure of angle SQR equals the measure of angle PQR. Angle addition postulate. In other words, this small angle plus this small angle equals the entire angle. Again, kind of intuitively obvious, but there it is. Next slide. Example 3, using the angle addition postulate, the measure, this is given, the measure of DEG is 115. I'm going to put a 115. I'm going to label some things here. And DEF is 48, so I'm going to put a 48 degree right there. Find FEG. So find this angle right there. So your choices are, do we add or do we subtract? It looks like we're going to subtract. 115, subtract the 48. So I need to borrow, make that a 0, 15, that's what, 7, 10 minus 4 is 67. So it looks like this angle here would be 67 degrees. We subtract to get that. Let's try another one. Angle bisector. Bisect means to cut in half. So we're cutting the angle exactly in half. Angle bisector is a ray that divides an angle into two congruent angles. It splits it exactly in half. This JK, this ray right here, I'll highlight it in blue, is my angle bisector. And it splits this half into this half. So they are congruent, they are equal. Let's do one more problem dealing with a bisector. It says KM bisects angle JKL. JKM is 4x plus 6. So I'm going to put a 4x plus 6 right in there. And then it says MKL is 7x minus 12. So the other small one is 7x minus 12. Find the measure of angle JKM. Nope, I did that wrong. This 4x plus 6 is JKM. Nope, I'm right. 4x plus 6. I did this right. Sorry. JKM is 4x plus 6. MKL. Yeah, so the two small ones are 4x plus 6 and 7x minus 12. And to solve that, my equation would just be 4x plus 6 equals 7x minus 12. Let's subtract 7x That gives me negative 3x plus 6, negative 12. Again, I subtracted the 7x. Now solve that algebraically. Subtract 6 to get negative 18. Sorry, making some mistakes here. It's supposed to be negative 3x is negative 18. So now divide by negative 3. X is 6, but that's not my answer. Remember, we've talked about that. X is not 6. I want to find the measure of JKM. So I plug it in 4x plus 6. So I got to go 4x plus 6, and I take this answer and put it in place of x. To get 4 times 6 plus 6, that's what, 24 plus 6 is 30 degrees. 30 degrees would be my answer. Okay, that's your notes for section 3. Thank you for watching.